Hello everyone, my name is Nicolas Cortés. On previous videos, I showed you some of my video game projects in which I didn't program much. There was next to no code in them. So I want to show this. This is a notebook, a Jupyter notebook, where me and my team used predictive models to make a prediction using Python libraries. I installed this with an account. You can see it here. It includes Jupyter, the Spider library, I think, NumPy library, Pandas, Matplotlib, TensorFlow. I use all of these. Well, not all of these, some of them. I use some of these to develop this project. I installed the Python 3.7 version, and I'll show you what we did. So here we initialize some things. For example, we import the NumPy library, the Pandas library, Matplotlib, Seaborn, and a bunch of other libraries that we're going to use for our models. For example, decision tree classifier for random forest. Here it is. I think this one is for random tree only. This one is for random forest. Decision tree. So let's see what else we find. This is a function that I created to convert the values that are words into values that are numbers, so the model can work. So here we are loading some files. We have all these data sets that we put into data frames. This is a sample. This is what the data frame looks like. So we have some x coordinates, y coordinates, an ID, a year, etc. So the purpose of this project was to predict if in an accident there was going to be some fatality. So with this we try to predict if somebody is going to die. So at the end we get a number which could be 1 or 0. If it's 0, then in that accident nobody will die, but if the number is 1, then there's a high probability that somebody will die, one person or more. So here we are treating the data. We're just showing the data from various years, from 2013 to 2017, if I'm not mistaken. Yes, that's right. Here we are cleaning the data frames. So for example, this is all commented. We are not using this, that's why it's all in comments. Let's see. Here, for example, we have this column name which says M grave, which means, well, it's pretty much the same as it is in Spanish. This is M and grave, which means menos grave, or how do I say it? It means less grave. So basically this means that the person has some injuries, but they are minor. This pretty much means minor injuries. This is the name of the street, the first street and the second street, because the accident could happen in an intersection. So we changed that just to words, not numbers, because we want every column to be in the same format. Every column has to be the same name, so we can merge them. There's a lot of cleaning here for the various years, changing the name of some columns and merging them together so we can work with every year and not just 1 year. So here is the name of the columns and the amount of data that we have. We have 2066 registers here. Here we have less. So we had to figure out what was happening. The idea is that they have to be like this, like every single one, where there's one here that fails. But the idea is that they all have to have the same amount, and if there are null values, then you can replace those null values with 0, for example, or with another number or string that you want. So here we are dropping some columns that we're not going to use, like the city, because every accident happens in the same city, so we don't need to have that value here. Here we have the different values that this column can have. So accidents can be either 1, 2, 3, 4, 5, 6, 7, or 8. And here's the amount of registers that have that number in their accidents column. So here we are visualizing what we have. We are replacing some names because they're not written in the same way. I'm going to go down a little faster so we can go to the modeling part. Let's see where here we have our correlation map. So you can see that the deceased variable is strongly related to this Boolean value. This is fallecidos means it's a Boolean variable. So if it's 0, then there are no deaths. But if it's 1, then there's at least one deceased. Now, I should really double check if I'm saying this correctly, but whatever. So these are strongly correlated, so they are interfering with our model. We eventually dropped one of them. We dropped this one, which is the amount of deaths, and we only keep the Boolean to know if there is one death or none, one or more or none. So here we're making groups. The idea is that there should be like this one. They are all around the same height. Here we can see that this one has a lot of values, but these ones have next to none in comparison. So we have to try to group them in such a way that they look kind of like this. But if they look like this, for example, it's not too bad if let me tell you with an example. But I can come up with an example, but you sort of have to tell if you can group them or not. And if you can't group them, well, there's nothing you can do. You have to leave them as they are. And then if the model is not working as you expected, then you can go back and make some changes, because you can change this part, for example, or this block of code, and everything else will remain the same. So let's go. Here you can see that they are a little bit more balanced. There's not much difference from here to here. I mean, there is the difference, but it's not as minimal as we saw in other variables. So here is where I wanted to get. we separate our data in two groups, training and testing. So we use the training data to train the model, so the model can learn what to predict based on the variables that we give the model as input. Then the model will give us an output, which is our prediction. So we train this data, and then we use this trained model with our test data to see if it predicts correctly or not. So here we have our random forest model with a score of 0.97, 978, 35, etc. This is pretty much 97%, which is pretty good. This is our confusion matrix. So these ones are good values, and so are these ones. These ones are not good because basically these mean that we predicted that there was at least one death, and then it turned out that there was no death. And the other one means that we said there are no deaths, but then the data says actually there is at least one death. So these are the ones that we got wrong. These are the ones that we got right. So it's not bad. So here we can visualize the ones that we got correctly, which are represented by this red bar. This green bar represents the total of data. So we got pretty close, above 90% of accuracy. This is the importance of every variable. So if a variable is here, we can more clearly see if a variable is interfering. So we could delete it and see if the model improves its result. We actually dropped the intersection variable. We dropped it, and we tried again, and we got 97.98%. This is the new importance graphic chart. Then I'm going to show you another model that we used. One was linear regression. Here it's all the code that we implemented. This chart doesn't represent very well the results, but we made it anyway. We still have our score predictions. Here is the model accuracy, which is 94 or 95%. So it's pretty good too. This is the important chart. This variable is more important. These ones are not that important. And the last model that we used, this is the chart where we compare the ones that we got right versus the total. The last one that we modeled was an ADA boost model. This is the Gini importance. We dropped one of those variables, and we ended up with an accuracy of, let's see where it is. This one, 94.5%. Here's the chart. And this is just our data. As you can see, they are just numbers. This is the way the model works. It doesn't work if we have strings, words, or stuff like that. So this one was just to show you that I also code. This is written in Python. And as always, you can go to my Bitbucket, and here you have the predictive model for car accident fatalities repository. You can click on it. Here we have this folder. If we open it, here it is the code that I just showed you. We can go back. This doesn't matter. I think this is the same that we have in this folder. No, I think this one is the code, and these one are checkpoints, if I'm not mistaken. These ones are the CSV files. These ones are some other CSV files that I think we didn't use. We used these ones. And if you want to download this repository, you can click downloads and then download repository. You will get a zip file that you can extract with WinRAR or 7-zip, and you'll get the code that you can check out by yourself. You need Jupyter to open it and see it. So that's all for today. I hope you enjoyed it, and see you in the next one.